Hello, Algebra 2 students. Today we are going to be looking at a video, 6.6, Solving Equations with Radicals and Rational Exponents. So this first slide you see here are the 4 steps that we're going to be taking to get to our solutions. First step you see is isolate the radical to one side of the equation. Second step, raise each side of the equation to the reciprocal power to eliminate the radical. Yikes, that's a lot of words. You'll see what I mean here in a minute with that. We're going to simplify and solve for x. Real important in these that we check our solutions. Okay. Sometimes our solutions will fail or produce an untrue answer, and so then we discard that solution. So here we go. Let's take these 4 steps and put them into action. Shouldn't be too bad. Alright, so first thing we do, we look at number 1. We're going to solve, we're going to check our solutions for extraneous solutions. Again, those are solutions that won't produce a true answer. So number 1, we have cube root of x minus 4 equals 6. Step 1 is to isolate this radical term right here. So I'm going to add 4 to both sides. And I get the cube root of x equals 10. Okay. Now to undo a cube root, I cube both sides. So I'm going to cube both sides. The cube root and the cubed will undo each other. I get x equals 10 to the third, which is 1,000. Now here's the important part. Let's check our work and make sure that 1,000 actually is a solution. So I take 1,000, I replace it in x in the original equation. So I get the cube root of 1,000 minus 4 equals 6. Cube root of 1,000 is 10. 10 minus 4 is 6. So 6 equals 6. Our solution checked. Let's do it again. Okay. So notice this time that we have a radical on the right. It is a square root. We have more than one term on the left. So pay attention what we do because this radical is already isolated. I start by undoing that square root by squaring both sides. On the left, the square root and the square undo each other. I'm left with 7x plus 15. Remember that x plus 1 quantity squared means x plus 1 times x plus 1. That we cannot distribute an exponent over addition. But rather I write these quantities twice and then I have to FOIL. So I get x times x, which is x squared, plus x plus x plus 1 equals 7x plus 15. And let's take a minute and look at this step right here and see what we've created. Okay, we have an x squared, we have a bunch of x's in there and some constant terms. If you're thinking we've created a quadratic, you're exactly right. To solve a quadratic, we have several options. We can factor, we can use quadratic formula, we could isolate the variable. So let's get all of our terms on one side and see if this equation will factor. So before I do that, I'm going to clean this up. I have x squared plus 2x plus 1 equals 7x plus 15. Now I'm going to take the 7x over here with the 2x, so I'm going to subtract 7x. I'm also going to take the 15 over here with its like term, so I will subtract 15. And I have x squared minus 5x minus 14 equals 0. Again, I have a quadratic. All my terms on one side in standard form set equal to 0. Now I will factor, and I have x minus 7 times x plus 2 equals 0. What multiplies to negative 14 and adds to negative 5. So our solutions are x equals 7 and negative 2. Before we move on, we have to check our solutions in the original equation. Notice that's before I've squared both sides. So I'm going to come down here and check to see if 7 and negative 2 actually work. So I plug in 7, I get 7 plus 1 equals the square root of 7 times 7 plus 15. I get 8 equals the square root of 64. So 8 equals 8. Check. Now I'm going to check negative 2. I get Negative 2 plus 1 equals 7 times. Tell you what, Miss Mason is loud. Here we go. So I've got negative 1 equals the square root of 1, and I end up with negative 1 equals 1, which we know negative 1 does not equal 1, which this means this solution is extraneous. So what do I need to do? I'm going to change colors here to highlight that this is extraneous. If this solution doesn't work, I'm going to come back up to my original solution and I'm going to get rid of it. So my only solution here that works is x equals 7. So that's what I mean when I say check for extraneous solutions. When you plug them back in and they produce a false statement, then we have to go back and discard that solution. Okay, so let's take a look at some more. Alright, so this one, 7 times x to the 3/5 equals 56. So going back to step 1, remember step 1 was to isolate the radical. So even though this doesn't look like a radical, it's a rational exponent, it could be turned into a radical if we wanted to. So we need to isolate. Start by dividing both sides by 7. So x to the 3/5 equals 8. Now, instead of turning it into a radical, we're going to use the idea of raising both sides to the reciprocal power. Because remember, when you do power to a power, you multiply. So if I raise both sides to the reciprocal power, which is 5/3, okay, I've got 3/5 times 5/3. Well, what is 3/5 times 5/3? Well, you're right, it's 1. When you multiply these, they undo each other, so you're left with x equals 8 to the 5/3. Well, we can't leave it like that. We've got to simplify 8 to the 5/3. So what does that mean? X equals the cube root of 8 to the 5th power. And the cube root of 8 is 2. 2 to the 5th power is 32. So before we go on, you're right, we have to check our answer. This is what we got, x equals 32. Here's our check. So we have 7 times 32 to the 3/5 power equals 56. Well, let's check that. That means 7 times the 5th root of 32 cubed equals 56. 5th root of 32 is 2. 2 cubed is 8. 8 times 7 is 56. So our solution works. We are good to move on. So let's try that idea one more time. Again, another rational exponent. Notice the difference between 3 and 4. 3, we had to start by dividing both sides by 7. We can't do this here because of the parentheses. Both of these terms are raised to the 3/4 power. So on this one, we start by raising both sides to the reciprocal power, which would be 4/3. So 3/4 times 4/3 is 1. Leaves me with x plus 3 equals 27 to the 4/3. Continuing to simplify, I get the cube root of 27 to the 4th. X plus 3 equals cube root of 27 is 3. 3 to the 4th is 81. And then finish by subtracting my 3. So x equals 78. And again, before I can go on, I need to check for extraneous solutions. So I check my 78, and it looks like this. 78 plus 3 to the 3/4 equals 27. And let's see, that gives me 81. So 81, I'll have the 4th root of 81 cubed. 4th root of 81 is 3. 3 cubed is 27. This one checks. Okay, so far we've seen 4 different examples. We've seen an example that contains an extraneous solution. Now I want you to try a couple on your own. Maybe if I can get my slides to switch. Hold on. Oy. There we go. Okay, so here are the two examples that I want you to do on your own. Okay, my little hint for you on number 5, when you square both sides, you have to expand this, x minus 8 times x minus 8, just like the second example that we did. Okay, we'll go over these in class. Thanks for watching my video.